Hello dear students, welcome back to the online classes. Today this is the fifth lecture on the topic relation and functions. But in today's class we are going to learn some various types of functions. Before I type or before we learn the topic functions or types of functions, we should know what is a function. Let me begin with the definition of the function is: let capital A and B be two non-empty sets. Then a rule or a corresponds F which associate to each element of capital set A a unique element denoted by f of x of B is called function from A to B and written as f from set A to set B. My dear students, this definition we can understand better by this Venn diagram. Let A be a non-empty set and B is also a non-empty set. The elements of the set A are A, B, C and D. There is a correspond between these two sets. FBA corresponds. The elements of B are 1, 2, 3, 4, 5. Now, the definition of the function goes like this. Every element of set A is F associated with unique element of set B. Then such a relation is called a function. Now if you observe here, A has an image 1, B has an image 2, C has image 3 and D has image 5. That is, each element of set A has a unique image in a set B. That's why this f is called a function and is written as f from A to B. Also, we can write this as f of A is equal to 1, f of B is equal to 2, f of C is equal to 3, f of D is equal to 5. Therefore, 1, 2, 3 and 5, these are called the images of the main set. The set A is called domain and set B is called the codomain. Now we will study what is domain and codomain. Let f from A to B be a function, then the set A is called domain of f and the set B is called a codomain of f. Now let me define what is a domain. The element of set A is called domain. The elements of the set A are called the domain. In the previous slide's example, the domain elements are: A is a set containing A, B, C and D. That is, each element of the main set A is called domain of the set A. Codomain. The elements of the second set B is called codomain. And in this case, B is a set containing the elements 1, 2, 3, 4, 5. And the range of the function is: the set of images is called range of the function and range R is equal to 1 2 3 5. Dear students, in the previous slide we have seen A is 1, the image of B is 2, the image of C is 3, and the image of D is 5. Therefore, the collection of images is called a range. Now, this is the definition about the function, domain, codomain, and range of the function is. Now, we are going to study some more examples to understand what is a function is. Look at, my dear students. If I take two non-empty sets A and B, and there is a correspondence between these two called F. F is a mapping between these two. A is a non-empty set and B is also a non-empty set. The elements of A are 1, 3, 5, 7, and the elements of B are X, Y. A is called domain and B is called codomain. The image of 1 is X, the image of 3 is also X, the image of 5 is Y, the image of 7 is also Y. Now we have to see that F from A to B is a function or not. Now we have to check the definition. All the elements of the set A have the single image. 1 has a unique image. 3 also has a unique image. The image of 1 and 3 is a X, that is a common image. Likewise 5 and 7 also has a common image Y. But these all elements have that unique image. Therefore, the such relation is called a function F from A to B. A is called a domain and B is called a codomain. Therefore, in this example, the domain elements are 1, 3, 5, 7. The codomain elements are X, Y. And just now we have seen that the range X and Y are the images of the given set A. Therefore, the range R is nothing but the elements containing X and Y. Therefore, F from A to B is a function. Let me define one more type, or let me check whether the given function is a relation or not. Suppose the element 5 has two images. The image of 1 is X, the image of 3 is X, the image of 5 is also X, and the image of 5 is Y, and also the image of 7 is Y. F from A to B is a function or not. Now in this case we observed that F of 5 has two images, one is X and another one is Y. 5 has no unique image in a set B. 5 has two images. Therefore, this type of relation is not a function. Now, in this case, F from A to B is not a function because 5 has two images. Therefore, such a relation is not a function. Let me take one more example to understand the definition of a function. Consider once again two non-empty sets. One is called a domain, another is also codomain, A and B. There is a mapping between A and B. G is a map between A and B. The elements of X, A are, it is P, Q, R. The element of B is just X. Therefore, the image of P is X. The image of Q is also X. In this case, you have to check whether the relation R is a function or not. Now in this case, according to the definition, every element of set A must have the unique image in a set B. P has the image X, Q also has the image X, but R do not have a image in a set B. Therefore, f from A to B is not a function. Is not a function because there is no image of the element R in set B. Dear students, now we are going to study the various types of functions. The first type is called a constant function. Let f from A to B defined in such a way that all the elements in capital A have the same image in set B, then it is said to be a constant function, and it is denoted by f of x is equal to c, where c is a constant. For example, suppose if I take y or f of x is equal to 5. A and B are the two non-empty sets, and A has or X has the elements like f of 0. The image of 0 is 5. F of 1. The image of 1 is also 5. F of 2. The image of 2 is also 5. For any value of x, the image of all these elements is 5. Such functions are called a constant function. We denote by the horizontal line is called x-axis, the vertical line is called y-axis, the point of intersection is origin. If x is 1, y is 5. If x is 2, y is 5. If x is 3, y is 5. Therefore, if I join these 2 points, we get a straight line which is parallel to the x-axis. Such function is called a constant function. Now let me define identity function. Let f from A to B is a real valued function defined in such a way that f of x is equal to x for all x belongs to A is called identity function on the set A. The nature of this function or the graph of this function is shown as below. Let me consider the x-axis and y-axis. O is the point of intersection. The function is defined as f of x is equal to x. X is a domain and its image is y. If x is 0, y is also 0. It gives that point of intersection O. If f is 1, that gives its image 1. If x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. If x is minus 1, it gives minus 1. If x is minus 2, it gives minus 2. And if I join, we'll get a straight line which is passing through the origin. Such function is called an identity function. The nature of the graph is a line which is passing through the origin. Now let me define the one more type of function, that is called a polynomial function. A function is of the form f of x is equals to a naught x to the power n plus a2x to the power n minus 1 plus a2x to the power n minus 2 plus a3x to the power n minus 3 plus so on plus an, where a0, a1, a2, a3 and an are real numbers, is called a constant, and this is a function of degree n. Therefore, the such function is known as a polynomial function. Dear students, I hope you have understood the definition of function and various types of a function. With this, I conclude my today's lecture. If you have any queries, please contact the following given number. Thank you. Stay safe.